Okay, let's look at your homework sheet from the other night and let's go over it. We have direct proportion. Question A says, is X directly proportional to Y? Did you put yes or no?
Yes.
Why is it yes?
Because
Well, it's not multiply, it's what? Divide. If we divide each time, we get 5 as the constant. So what would the equation be?
y equals 5x.
And it's always going to be y equals a number variable. Y equals a number variable. Y equals a number variable. If it's always like that, that is a direct proportion. Okay, let's look at number 2. Can we divide each time and get the same constant on number 2?
Yes.
And what is that constant when we divide? We get 25 every single time. So the answer is yes. The constant is, what's the equation?
Y equals 25x.
Y equals 25x there. Okay? All right, number 3. Can we divide each time and get the same constant? No. What's 130 divided by 2? 100 divided by 4 is, so we don't get the same constant, therefore it's no. We can't find a constant, we can't write an equation for that one. Okay? Number 4. The table below shows the distance traveled x and the amount of gasoline used. Tell whether y is directly proportional to x. If we divide each time, what is our constant? We get 12 and a half if we divide each time. So yes, the constant is 12 and a half. We're going to skip the word description. And what is the equation? Y equals 12 and a half x. Good. Okay, flip over. Okay, if we divide each time on the number of machines and the number of tennis balls, 60 divided by 3 is 20. 100 divided by 5 is 140 divided by 7 is. So is it directly proportional? What's the constant? Don't worry about the word description and give me the equation. Y equals 20x. All right, number 6. Does this equation fit our direct proportion equation? Is it the same format? Does it look the same? Y equals something x, yes? So then yes, this is a direct proportion. What's the constant? Huh? No, what is the constant? The constant is a number. 30. There we go. The constant is 30. So as long as it follows this format right here, it's direct. Now, if it looks like this, y equals 30x plus 4, that would not be a direct proportion because it has that plus 4 on the end. It has to be y equals a number x, and that's it in order to be direct. Okay, number 7. Is this the format that we need for the equation? P equals a number. Why not? Because it didn't have y and x. Doesn't have to be y and x. Just as long as it's a variable equals a number variable. So yes. Remember, these letters can be any letters. And what's the constant? 0.25. Okay, Emily worked in a florist shop for 3 hours and earned $36. Given that the amount she earned, y dollars, is directly proportional to the time she worked, x hours, identify the constant of proportionality and write a direct proportion equation. So what's the constant? Mm-mm. 3 hours for 36. Nope. So what would the constant be? 12. Why 12? Well, what are you trying to find? How much she earns in 1 hour. It's always about the 1. You always have to find that unit rate. So 12 is the constant. So what's the equation? Y equals 12x. Okay, the next one. Jim rode his bike at a steady rate of 20 miles per hour. Given that his distance, d miles, is directly proportional to the time he rides, t hours, Identify the constant and write the equation. So what's the constant this time? 20, good. What's the equation? Y equals 28. Good job. Fabulous. Okay. Okay, take out a clean piece of paper, and we're going to title this piece of paper, Solving Proportions Involving Similar Figures. I'm going to do a mini lesson with you over similar figures, and then you have some Excel problems to do over similar figures. So go ahead and get your paper out and get the heading. This is your heading that you're going to write at the top of your paper. It's right here. You also need some type of calculator. So if you don't have a calculator, go up front and grab one. That's fine. Calculator. Get your title written down on your paper. All right, we're looking at solving proportions that involve similar figures. Similar figures are the same shape, but they're just different sizes. And you may have solved these last year. I'm not sure. Did y'all do these last year?
Yeah, we did.
Yeah, where you have to find the value of the unknown length, kind of. Okay, all right, so let's get started. I don't want you to draw the shapes on your paper. I'm just going to have you actually set up the proportion on your paper, okay? So you're going to be working along with me as we solve a couple of these together. All right, when we look at number one, we have two rectangles. One is little and one is big. All right? So we're going to start, we're going to put a 1 here. This is our first one, and this is our second shape, okay? On your paper, I want you to come down and draw 2 fraction bars for your proportion. We're going to start with our first shape, and we're going to start with the side that's labeled as 9, okay? So we're going to put a 9 on the top. Now, on the second shape, what is in the same position as the 9? X. So that's going to be on the bottom of 9. They go together. 9 and X go together. Now we go back to our first shape, because the first shape's number goes on top and the second shape's number goes on the bottom. All right, so now what's left on the first shape? A 1. So we're going to use the 1 from the first shape. And what does it match on the second shape? A 12. So that's how you set your proportion up to solve for this unknown side right here, which is X, okay? So now we're going to use our cross multiply and divide to solve this. So take your calculator. We're going to cross multiply 9 times 12, which is what? 108 left over. We divide by 1, so we get 108. So this length is 108. So X equals 108. And we can check it. See how we can check it? If we have 9 over 108 is equal to 1 over 12, we can use the butterfly to check it. 9 times 12 is what? 108. 108 times 1 is what? That means you solved it correctly. Okay? All right, let's look at number 2. Number 2, we have 2 shapes. Let's go ahead and draw our fraction bars here. We have our first shape and our second shape. Okay, so here's our first shape, here's our second shape. So we're going to do our first on the top and our second shape numbers on the bottom, okay? All right, so we're ready. Starting with the first shape, which one do you want to start with, X or 8? Doesn't matter. X? Okay, so we're going to start with X. So X from the first shape matches with 16 from the second shape. Okay, now we have to go back to our first shape. What do we use? 8 from the first shape goes with 32 from the... Okay, now what do we do to solve this? Okay, 16 times 8, so go ahead and do that in your calculator. Sixteen times 8 gives us 128, and then what do I do? Divide by the leftover number, which is 32. So divide by 32 equals 4. So X is equal to 4. The unknown side was 4. What do you think so far? Pretty easy? Okay, let's go to number 3. Let's do a third one. Okay, here's our first. Here's our second. So let's set up our fraction bars here for our proportion. First goes on top. Our second shape numbers go on the bottom. Okay, choose something to start with from the first shape. Okay, so we want to start with 12. 12 matches with what from the second shape? X. Okay, now let's go back to our first shape. What do we choose? 10. And it matches with 5 from the second shape. Okay, now we're ready to solve it. So what do I do? 12 times 5, which is 60. 60 divided by 10 is, so X equals 6. Okay, number 4. Let's do another one. Okay, so we have our first shape and we have our second shape. So first on top, second on bottom. Okay, give me a number from the first shape that we want to use. So 4 goes with what from the second shape? X. Okay, then what? From the first shape, 10, which goes with 70 from the second shape. Okay, now we cross multiply and divide. So 70 times 4, which is what? 280. And then what do I do? Divide by 10, which is X equals 28. Who feels like they got it? Okay. Number 5. I'm going to label first and I'm going to label second. You set it up and see what you get. I'm going to let you fill it all in. Go. Got an answer? Okay, tell me how you set this up. Where did you put on top? 10, and then X, and then the second one, 11, then, Okay, so 10 times 88, 880, and then divide by 11, which gives you 80. So x equals 80. Okay, the one last thing that I need to tell you about similar figures, okay? For similar figures, their angles are exactly the same in both shapes. Okay, so let me blow this up and show you what I mean. See how these are both triangles? One's big, one's little. Okay? This angle E matches with B. Do you see that? They're both 44 degrees. D and A match. They're both 102. F and C match. They're both 34. Does that make sense to you? So similar figures, you don't have to worry about solving or doing anything special for the angles, because if you know the angle of one, you know the angle of the other one. They're going to be exactly the same angle measures. If I were to actually trace, see if I can trace it. If I trace this shape right here, got a little bit off right there, and I take it and slide onto this one, see how those angles, that's angle B, see how it matches up exactly? Here's that one, it matches up, and that one matches angle F. Do you see that? The angle measures are exactly the same. So if I were to give you two similar figures like this, for example, and let's say you don't know these two measures, what would be the measure of angle J? Which one does it match? Does it match F or does it match G? Okay? If you look, here's the straight side with the little box. The box is facing over here. So if we go that way, does that help you to figure out which one it matches? Okay? So J is 28. What's L? 52. It's 52. Okay? So you get the same measures. Okay, let's look at this one. Would these shapes be similar figures? Why not? They don't have the same angles. Now they look like they're the same shape, but their angle measures do not match up. Therefore, they're not similar figures. Okay. Let's look at this one. Just by looking at the lettering of similar figures, we can figure out angle measures. Blow this up so we can see. Okay, let's look here. Triangle CAN, and draw this on your paper. Draw this on your paper. Triangle CAN. Blow it up a little bit more for you. Triangle CAN, and this symbol right here means similar. That means similar. Triangle CAN is similar to triangle JOY. CAN JOY. Okay, it says measurement of angle A is 96. So here's A right here in the middle. It's 96. Can you tell me what from JOY will also be 96? Oh, good. See that? You don't even have to have a picture. So we know that O is also going to be 96. Okay, it says N is 46. So here's N. It's 46 degrees. What else is 46 degrees? Y. Y is going to be 46 degrees. Okay? And then it says that C is 38. So what else is 38? J. Okay? So do you see how just from the lettering you can get information? Yes? We don't have to have pictures to figure out the angles. We could match up the letters and figure out the angles. Okay, I'm pretty much done with similar figures with you. At this time, you're going to get on to iExcel, and you are doing P13. I think it's P13. Let me double check. I'm going to get on there too. Under 7th grade math, right here, P13. P13 is where you're going. Do you see how some of these are flipped? So you may have to trace it and then turn it before you set up your proportion, okay? You may have to draw it and then turn it so it sits in the same way. P13. Some of them will ask you to set up proportions to solve for sides, and some of them will ask you about angles. P13. iExcel P13. You will continue to work on P13 until you get a 90 on it. And I will be walking around to help you, or you can ask for help. I don't have markers. If you have your own marker, you're welcome to use a marker board. If you have your own marker, you can.